Okay, how are you everybody? How are you my local students?
We are fine.
Thank you very much. And how are you online community? I would like to take this opportunity to welcome you into our second lecture or our first lecture or first workshop that's called Introduction to Practical Electronics Engineering. And actually this is the continuations of the previous lecture or previous workshop, which was workshop 0 or lecture 0, where that I've introduced to you or I've been teaching about general introductions of fundamental, the beauty of fundamental of practical electronics engineering. So that's what we've been discussing about that. And I would like to ask you to join me at this time. And in case you have questions, you may also ask for this because I have some local engineering students who would like also to learn engineering and technical students who would like to learn and understand and practice what you are going to cover today. So in case you have any question, you should not hesitate. Like students to interact with me. And I have a good news for you today because I have to take you from one point to another point. So you may ask your questions in either Swahili language or in English language, but it's better to practice English language, right? Yeah, because you are engineer and possibly that you'll be putting all your informations in English language. So it's better to practice, you'll be doing some presentation in English. And you know that learning engineering or science in English is a little bit easier rather than learning in Swahili language because some of the terminology you fail to translate them. So most people, they used to say that, for me, I like to speak Swahili. I would like to speak about engineering in Swahili language. But actually, they are speaking Swanglish, both English and what? Yeah, because, for example, how do you call transistor in Swahili? Okay, so you can find that maybe it's called a transistor, but transistor is actually that it's a word which has been borrowed from the English language. So you find sometimes that even you don't find them the conducive environments of presenting your information because what you are saying or what you are pronouncing sometimes is a little bit different from the language you're using. Okay, so that's the point. And this course, we have the course because we have our online schools in diploma and graduate departments of electronics engineering. And then the course or the modules is called the beauty of fundamental of practical electronics engineering. And this is workshop 1, introductions to practical electronics engineering. So if you remember the list of the chapters that I've presented in previous session or previous lecture, this is chapter 1. Okay? So I would like just to do the quick review. Of what we have covered in the previous session. Say quick review.
Quick review.
Say quick review.
Quick review.
Quick review means that I'm reviewing what you have learned in previous lecture, and after it was lecture 0, which has been titled as General Introduction of what? The Beauty of Practical Electronics Engineering. What did you learn? Right? Actually, these are the few things that you have learned. Firstly, I've mentioned the 5 fields. Okay, 5 fields of general of the beauty of practical electronics engineering. Right? The beauty of practical electronics engineering, I've mentioned. Can you mention them? The first one is what? Electronics engineering. Second field is biomedical engineering. The third one is electrical engineering. The fourth one is telecommunication engineering, and the fifth one is what? Computer engineering. So I told you that the knowledge you are going to learn from this module can be used across all of those fields. Those are the some main fields, but even mechatronics engineering, you need this knowledge. Okay? So that's why that I've mentioned that this module actually draws its content from 5 fields. Are we together? The only thing that you won't see here is maybe programming, because we won't deal with programming in this module. And then I presented to you about I talked to you about how many specific objectives? 7 specific objectives. So 7 specific objectives. Say 7 specific objectives.
7 specific objectives.
Of the beauty of practical electronics engineering. So I've mentioned or I've presented 7 specific objectives of this module that a student has to achieve at the end of its completion, right? Can you remind me one of the specific objective? Can you check on your copybook? Can you remind me one for the local students? One of the specific objectives that you discussed, can you speak loudly?
To teach students the fundamental idea on 5
multidisciplinary fields. So to teach students what is fundamental ideas in 5 multidisciplinary fields. That's one of the specific objectives. Hilda, can you mention one of the specific objectives?
To relate the theoretical simulation and the practical concepts of electrical engineering.
Of electrical engineering. Did you say electrical engineering or electronics engineering?
Electronics.
But with mindset that of electrical engineering. But because we are discussing about low power, that's why that we use the word electronics engineering. So in case that you missed, you can still access this the contents because you have a video for that. So there's no need for us to spend much of the times there. Then the third concept that I have told you is about contents. Do you remember?
Yes.
Contents of of the beauty of practical electronic engineering. Practical, the beauty of fundamental practical electronic engineering. The beauty of fundamental practical electronic engineering. So how many contents? I say that I organize the contents of this module in form of chapters, right? So how many chapters do we have? 12 chapters, right? So you have 12 chapters. So it means that we have 12 chapters. And I've just mentioned the chapters and discussed a little bit, but I didn't do demonstration. So this is our beginning now. It means that after that, it means 12 chapters. We had the first chapter here. So can you, okay, the first chapter we say, how is it, do we call it Introduction to Practical Electronics Engineering. The second one, Practical Electronics Benches. The third chapter,
Electronics measuring and testing instruments.
Electronics in measuring and testing instruments. The fourth chapter,
The beauty of resistors.
the beauty of resistors. The fifth one,
The
beauty of capacitors. Then the sixth one,
The beauty of inductors.
beauty of inductors. Then the seventh one,
Beauty of diodes.
beauty of diodes. Then the eighth one,
The beauty of bipolar junction transistors.
beauty of bipolar junction transistors. Then the ninth topic,
The beauty of electromechanical switches.
electromechanical switches. Then next one,
The beauty of transducers.
transducers. Then the 11th one,
The beauty of basics of telecommunication engineering.
so telecommunication engineering. The last chapter is
Solving small-scale electronics real-life problems.
real-life problems. Wonderful, wonderful, wonderful. I'm very happy to hear about that. So before we go into today's contents, because today we are going to start with the first chapter that called Introduction to Practical Electronics Engineering. And but also I think that before we ended the session, I left it homework 0, 0. Do you remember? Yes. How many questions? 4. The first question, what is what?
Science.
Yes, what is science? Then the second question, it is what?
What is mathematics?
What is mathematics? Oh, so what is mathematics? The third question is what?
What is engineering?
Yeah, what is engineering? You're studying engineering. Do you know its meaning? The fourth question is what?
What is electronics engineering?
What is electronics engineering? So these are the 4 questions that I have left. But I told you that I'm not interested with a long or even a short or a medium sentence of definition. My interest is for you to see the big picture of electronics engineering from these technologies. Are we together? So I know you know the definitions, but maybe you have never thought that how can you draw electronics engineering from these technologies? And this lecture, or the lecture of today, or the workshop of today, will give you at least the big picture of electronics from these technologies. Right? So before I start to teach you about introductions to practical electronics engineering, let me do some demonstrations of what we are going to enjoy in this module, right? So for introductions to practical electronics engineering, Well, actually, this is what, so it means that actually the main focus here is to see the big picture of electronics engineering, right? And then once we comes into the practical electronics benches, say practical electronics benches.
Practical electronics benches.
Okay, we have different hardware and software electronics benches. For the software electronics benches, I cannot demonstrate it to you unless that we have a computer, but we'll discuss that topic. But simply, these are the, just to recall them, these are the workbenches that we have in electronics. Mainly we have 3 of them. Okay, fundamentally we have 3 electronics, this we call them electronics hardware working benches. This is a breadboard, say breadboard. And then this one is called the veroboard, say veroboard. And this is called the PCB board, say PCB board.
PCB board.
Wonderful. So it means that with this one, it's just for testing, you cannot solder. Just you plug the components and the jumpers and, okay, yeah, mainly components and jumpers, right? But with this one, you cannot plug the components. You have to plug them and the solder, right? With this one, this is called the variable. So, but in this module, we are not going to cover about this. According to its timing, we'll cover it in intermediate, how you can use or how you can build your circuit in this board. Okay? Then again, here we have a PCB board. This PCB board is insulated, right? So here, this is plastic on this side, right? If you come to this one, it means that, for example, if you start with this variable, right? We have different types of variables. So this is the variable, this is the variable. But there's a difference in internal connection between this one and this one, right? So with this variable, what do you see on the top surface? Plastic. This is plastic, right? Is plastic a good conductor of electricity?
No.
Huh?
No.
Plastic is what? Bad conductor. So simply call it, it's an insulator of electricity, isn't it? Eh?
Yes.
But inside this board, there is copper material. So there is not copper actual, but there is iron material. You see this one? Eh? Yes. So it means that on top of it you have a plastic, but inside it you have good conductor of electricity, which you actually call them conductors of electricity. Are we together? Yes. But also it has been insulated with this material in order to avoid short, electric short. Are we together?
Yes.
Again, once we comes into this working bench, which is called the variable. The variable, it has 2 sides, right? One side is plastic, this side, the top side, it's plastic. So plastic, it is bad conductor of electricity. So we don't expect it to have a connections on the top surface, right? But bottom surface, it contains plastic and some copper holes. Say copper holes.
Copper.
So copper a good conductor of electricity or bad conductor of electricity? Good conductor of electricity. So it means that our connections will be focusing on those copper holes. Are we together? Yes. Are we together? Yes. So you should have a big picture of electronics workbenches. Means if in case you want to build a circuit in electronics, you might use either this or you might, I think this is compulsory for testing and practicing and being, because the aim of this one is to give you confidence that the circuit is going to work, right? Once you are satisfied, then you say, okay, let me build it permanently. So to connect the components. You can build it on this variable or on this PCB board. Are we together?
Yes.
Are we together?
Yes.
So this is what we call the Vero board. But to build a circuit in Vero board, you need also to do some other activities such as soldering, right? While when you are building a circuit on the Vero board, there's no need for you to solder the components. Are we together?
Yes.
The third working bench in electronics that we have is PCB board. So this PCB board, it has 2 sides. It is a single-sided board because on top of it it's plastic, but at the bottoms it's copper. But this copper, it has been protected because, for example, if just you take this one, nylon, so you see the greenish now, right? So that greenish, it's a chemical substance, and actually have to do etching process until you have a circuit like this one. This is the circuit, this is a PCB board I made myself, right? So before it was like this, right? So there's a process which actually that I cannot teach you in fundamental, I cannot teach you in intermediates, I will teach you in advanced, because sometimes I think that, yes, in intermediates we can cover it, yeah, in high intermediate we can cover how you can build these circuits, right? So it means that this one, actually the origin of this one, of this PCB board, was this one. Are we together?
Yes.
But now, why this is a fundamental? Because you are allowed, it means they will give you permission to test your circuit even 100 times without buying another breadboard. But once you build on this variable, and then you made a mistake, or maybe you want to do modifications, you have to find another variable board and start to desolder the components from this one, and then you solder on another new variable, similarly to this one. You cannot do modifications once you build it. At least for this one you can do some modification, but for this one you can't until you produce the new PCB board. Are we together, students?
Yes.
So this is hardware working, or we call them hardware, practical, electronic benches. Okay?
Yes.
I'm just demonstrating. We'll be dealing with them in detail. Then the third chapter is 8.20, electronic measuring and testing instruments. So you can pass by and check. Once I demonstrate, for the local students, you can check that the variable, right? And this one, just you don't take it, but you see some greenish. Okay, one day, I hope that you will be there and you'll be doing great things. We have also this, the PCB board. Isaiah, what are you doing? It's time for studying. Okay? So, those are the PCB boards. And unfortunately, I have just only one variable. So it means once you finish to check it, you pass it to your neighbors. Then the third chapter is what? Tell me chapter 3. Tell me chapter 3. Quickly.
I have a question.
You have a question?
Yes.
Okay, you're welcome. Dad.
What's the difference between variable and the strip board?
And strip board.
Yes.
I'm not familiar with strip board. I'm not familiar. It's my first time to hear strip board from you. It doesn't mean that I know everything, so you can share to me. What it means of strip board?
Strip board is the board which you used to make permanent soldering.
Ah, permanent soldering.
Yes.
So, I'm not sure. I think that I'll check the answer for that question there in the next session. I'll give you the difference. If there's a difference or they are the same. Okay?
Yes.
Or is there anybody else who knows the difference? Do you know the difference? Is there anybody who knows the difference between variable and strip board? No. Okay, so you have to look for it, right? Yeah. So then chapter 3 is what? Engineering students, you have to be in hurry. Wake up, please. Chapter 3 is what?
Electronics measuring and testing instruments.
Electronics measuring and testing instrument. That chapter actually gives you the fundamental idea of these measuring instruments and testing instrument. Listen careful. This is small multimeter. The simple meaning of multimeter actually is an electronic device, or it's an electronic, yes, it's an electronic equipment which contains collections of different measuring and testing instruments. That's the simple definition of multimeter, right? For example, this one, it contains an ammeter. But we also have two types of ammeter. We have DC ammeter and AC ammeter. But also it contains a DC voltmeter and and AC voltmeter. But also it contains continuity testing. So this one, the multimeter, contains measuring instruments and the testing instrument. A good example of measuring instrument is the C voltmeter. It measures the COT voltage. Another example is what? AC voltmeter. It measures what? AC voltage. Another example of measuring instrument is ohmmeter. It measures what? Resistance of the resistor. Are we together? Yes. So this small multimeter, it contains collections of measuring instruments. But also, this small multimeter, it contains collections of testing instruments. Testing instruments, these are the electronic instruments that we are using to test, only for testing. Testing what? For example, I want to test if there is a flow of electric current from point A to point B. I will need your continuity tester. Are we together? Or for example, I want to test here, I have a transistor, and transistor, bipolar junction transistor, it has base, collector, and emitter. So maybe from the data sheet, I've been told that number 1 is emitter, number 2 is base, number 3 is collector. But now, okay, that's fine. Can I test it? Yes. So I can take that transistor and put it in the transistor tester to test it, to verify. But also the transistor tester, it can give you the current gain of that transistor. And you have to compare with Zoti with the one that will be given from the data sheet of that transistor. Are we together?
Yes.
So now this is the big guy. So there's a difference between this one and this one, because this one, it can measure the quantities of electrical, maybe for example resistance or whatever, but in small range. But this guy can measure in wide range. Are we together?
Yes.
Are we together? So this also, it's a multimeter. It's big in size, but also it can give you some, for example, you can find that this one can measure maybe resistance from ohm to mega ohm, while this one can measure resistance from ohm to kilo ohm. You see the difference?
Yes.
Huh?
Yes.
Yeah, so these are the measuring. So even this one, it contains a collection of measuring instruments and the testing instrument. So in chapter 3, I will give you the overview. Actually, it is a broad subject, but I'll give you the overview that you need to apply. Right?
Yes.
Yeah, so because the broad subject, it means that we can teach you a particular knowledge in this module, but once we go into intermediates, we can take you further. Are we together?
Yes.
Chapter 4.
The beauty of resistors.
The beauty of resistors. So in electronics, we have different types of resistors, but basically the one that we'll be using frequently are these. So these the collections. For example, these resistors are, the resistance of these resistors is 270. Okay? We'll be discussing about them, we'll be discussing about the color code, we'll be discussing about how you can use them in the circuit. You see? So you have to take yours now. You are just watching me. You have a bunch of resistors. So this is a bunch of resistors. So once you have like this one, listen students and watch. Once you have this one, it means all of these resistors, they have the same value. Right? So they have the same value. If it's 220 ohm, all of them have resistance of 220 and 20 ohms. Are we together?
Yes.
Once you take the other ones, you'll find also it might be having a different value. Are we together?
Yes.
Are we together?
Yes.
So these are fixed resistors. However, in this fundamental program, I will teach about fixed resistor and variable resistors. And the variable resistors will be focusing on potentiometer. Right?
Yes.
Are we together?
Yes.
So you saw where are we heading to? Then chapter 4,
The beauty of capacitors.
the beauty of capacitors. I've been looking at my capacitors. Unfortunately, I didn't see them. But I didn't see them. I think that in the next. Yes, I have. You see? So for the beauty of capacitors, mainly we have polar and non-polar capacitors. And this is the polar capacitor. Right? Polarized duty capacitor. We'll be focusing on this because even on solving small scale real life problems, you need these capacitors to store charge. Okay, to store charge, sometimes it is reduced noise, so it has different applications, but the central functions of a capacitor is to store charge, especially polarized capacitors, because ceramic capacitors, they have some other activities. Are we together?
Yes.
So we'll be dealing with this stuff. We have small capacitors and large capacitors, but the largest capacitors, we call them super capacitors. Are we together?
Yes.
Yeah. And then the next chapter,
The beauty
so
of
I can see
inductors.
it. Just see, you have to take a watch of it. But this one also is a capacitor, right? You have the other one, eh? Okay, so good. So this is what belongs to you, eh? Okay, and the beauty of what? Inductor. I've been looking for inductor. Unfortunately, I didn't find it. Maybe I'll demonstrate later. But we won't focus too much on inductors according to the challenge of sometimes inductance meter. We don't have inductance meter. So that's why it will be a little bit difficult because you have to know what the value of that inductor. But at least it will just touch a little practically what is inductor. So once you have it in your hand, you can use it effectively. Okay?
Yes.
Then the next one,
The beauty of diode.
the beauty of diodes. So the beauty of diodes, we have different types of diodes. We have general purpose diodes that you can see in this circuit. These are the general purpose diodes. And then we have also what? Light emitting diodes that we'll be focusing on them because we need to use them. And I have given you some light emitting diode, and these are the others. So for the light emitting diode, we have 2 pins light emitting diode. We can have also colored light emitting diode of 3 pins. Okay? So 3 pins. So it means that that one can give you more than 1 color. Interesting. And I told you that yesterday, one of the small scale, you can make your a small what? A small lady marketing device. You remember that? Welcome to Saloon. Okay. So those are the some of the light emitting diodes. So this is the light emitting diode of 3 pins.